Looking at section 5, rational expressions. So we've multiplied polynomials, we've added and subtracted polynomials, we have factored polynomials. Now we're going to be looking at these polynomials in a different form, and we're going to try and combine some of these methods that we've talked about already into some bigger problems, because why not make them bigger? We're looking at polynomials in fraction form. So first, let's start with a very basic idea of, just to refresh your memory, to remind you what simplifying or reducing fractions, how that works. If you have 6/8 and you were asked to simplify that or reduce that fraction, a lot of you can spot out the answer, but let's make sure we understand what we're saying. 6/8 can be reduced to 3/4 or simplified to 3/4. And what that means, or how that works, is that we're looking at what can we divide both the numerator and the denominator by. What's the greatest common factor between 6 and 8 that we can factor out, basically. So we can divide them both by 2. And the reason we can do that is because 2 divided by 2, 2 over 2, this fraction here is just 1. 2 over 2 is 1. So really, we're doing 6/8 divided by 1. 6/8 divided by 1 is just 6/8. Like, nothing changes when you divide by 1. And so that's why 6/8 and 3/4 represent the same relationship, represent the same ratio mathematically. Algebraically, it works that we can do 6 divided by 2 and 8 divided by 2 and get 3/4. Algebraically, it works, or mathematically, it works because we're really dividing by 1. 2 over 2 is 1. So we're not changing what 6/8 means into 3/4. These mean the same thing. As a picture, we're looking at this. We've got this pizza, because I like pizza and it's yummy. We got this pizza, and we've divided into 8 slices. If I eat 6 of those slices, I'm going to have a terrible stomach ache, but I can do it. So I've eaten 6 out of those 8 slices. That's the same amount of pizza as if I cut the pizza into 4 slices and ate 3 of them. It makes me feel better to say I only had 3 slices of pizza. They're just ginormous slices of pizza. And so 3/4 is the same as 6/8. It's just more slices. Just like if you had 12/16. Now you cut your pizza into 16 pieces and ate 12 of them. It makes you sound like you ate a whole bunch of 12 slices of pizza, but it is the same as having 6 slices of pizza out of 8, or 3 slices of pizza out of 4. And so depending on the size of the slice, we're looking at smaller and smaller slices and just eating more of them. So it does work out that you can divide the numerator and the denominator, the top of the fraction, the bottom of the fraction, by the same number. We're basically factoring out a common factor between them and dividing them away to 1. 2 divided by 2 is 1. Okay, let's look at how that is. Wow, that escalated quickly, didn't it? We'll look at simplifying with polynomials here. Same idea. What we want to find is what's a common factor between the numerator and the denominator. And as it looks right now, I don't see one. We can't factor a 5 and a 6. We can't factor anything out of both 5 and 6, y and 1. However, we know how to take this trinomial, y squared plus 5y minus 6, and we can factor that. So let's see what happens when you factor that numerator. We're looking for 2 numbers that multiply to -6 that also add to 5. Well, let's see. 6 times 1 is 6. So how about 6 times -1? 6 times -1 would be -6, and 6 plus -1 would be 5. So I can factor that to y plus 6 and y minus 1. And again, the way I did that was I was looking for 2 numbers that multiply to -6, 6 and -1, that also add to 5. 6 plus -1 is 5, and you can FOIL this out to prove it to yourself. Why that's effective, or how that can be useful, is now there is a common factor between the numerator and the denominator. There's a y minus 1 being multiplied, and that is important. It has to be multiplied to everything. So we have this multiplication here. At the beginning of this problem, we didn't have a multiplication going on between 2 different things. Now we do. We've got this y minus 1 times y plus 6, and we have a y minus 1 in the denominator. What that means is we can divide y minus 1 divided by y minus 1, and that just divides to 1. just like back here, the 2 divided by 2 divided away to 1. When we do that, what we're left with is just y plus 6. We're basically, I'm going to say cancel because that's a term that's used a lot. We're canceling something from the numerator and the denominator. Y minus 1 and y minus 1 cancel themselves away, and we're left with just y plus 6. What's really happening is we're factoring out a y minus 1 from both the numerator and the denominator, and they're dividing to 1. And we're left with just y plus 6. So we can cancel those away with y plus 6. One thing to be careful of, you cannot divide by 0. Well, okay, how that applies to this problem. Yes, we have reduced it, we have simplified this original expression to just y plus 6. However, we have to look back at this original problem and say y plus 6 is great, but we have to be careful because while you can add any number to 6, y could be anything, 12, 17, 500 billion, and you could add 6, and there'd be no problem. Back here at the original problem, or the original expression, I should say, y minus 1 here causes an issue. If y were 1, 1 minus 1 would be 0, and we would be dividing by 0, and that can't happen. If y were 1, we'd have no issues on top. In the numerator, 1 squared plus 5 times 1 minus 6 is not an issue. However, 1 minus 1 is a problem. And so we would have one excluded value. And so if you see anything about an excluded value, what they're asking is, sure, we have this reduced expression, y plus 6, but are there any values for y that cause a problem back here at the original expression, where 1 minus 1 can't be 0? And yes, y cannot be 1. So we would say that this simplifies to y plus 6, and an excluded value would be 1. Y can't be 1. And that's going to come up later on in like chapter 6 too. Okay, let's look at these two. Again, we've done this before, or in the last video I did this, I'm going to do it again here. Pause it, try this on your own. It is different doing it on your own than watching me go through it. So please do pause it, try it on your own first. I'm assuming you paused, I'm assuming you tried these two on your own. I'm going to keep going. I'm going to show the answers. I think I'm going to show a few of the steps in between, but I'll go back and maybe do it slower in a separate video. If you factor the numerator and the denominator of this first expression, you'd have a minus 6 and a plus 2, and you'd have a plus 6 and a plus 2 for the denominator. What we can do then is say, okay, what can we cancel? How can we simplify this? Well, both the numerator and the denominator have a factor of a plus 2, so those divide to 1, and we're left with a minus 6 and a plus 6. And that would work. The excluded values, a couldn't be 6, negative 6. A could not be negative 6. Negative 6 plus 6 would be 0. That would cause a problem here. But also, going back a step, if a were negative 2 plus 2 would be 0. And 0 times 4 would still be 0. So if this were 0, we would also have a problem. So the excluded values for this the solution, the simplified expression here, would be a could not be negative 6, because negative 6 plus 6 is 0, and you can't divide by 0. But going back to that original expression here, a could not be negative 2 either. In the second expression, we could factor the numerator to a minus 4 and a plus 4. Denominator would stay the same, and we could simplify then and cancel or divide away the a plus 4 and the a plus 4, and we'd be left with a minus 4. The excluded value, again, going back to that original expression, a plus 4, if a were negative 4 plus 4 would be 0, and this would cause an issue. And so the simplified expression would be a minus 4, and the excluded value would be negative 4. All right, a handy trick. If we run into this issue where it's almost something we can cancel, a minus b and b minus a, those are almost the same, where we would love to be able to just cancel those away to 1, but it's in the wrong order, a minus b and b minus a. If this was an a minus b, we'd be set, or if this was a b minus a, we'd be set. There is a handy trick that we can use to work around that. And it works like this. In the numerator, or the denominator, but I'm going to use the numerator. In the numerator, if I divide a -1 out of both of those, if I factor out a -1, what I'm left with is b minus a. And you can see that if you distribute back through, -1 times b would be negative b. -1 times a negative a would be a positive a. There's that positive a. So a minus b is the same as -1 times b minus a. And that seems like a really trivial thing, like why would you go through that effort? But now that I've done that, now that I've factored out a -1 to flip-flop these around, I can cancel the b minus a and the b minus a. And b minus a over b minus a would divide away to 1. I'd be left with -1. Since we don't know what a and b are, we really wouldn't talk about excluded values so much in this one. Let's see that in practice. So here's another problem. I'm going to go through it step by step, but try it on your own. I mean, give it a shot, see what you can make of it. If you get stuck, then I'm going to go through the steps here. So if you have 4z minus 4z squared over z minus 1, we want to factor this. We can look at that numerator and say, well, I can divide a 4 out of both of those, and I can divide a z out of both of those. And so I'd be left with a 4z and 1 minus z in parentheses. So I could factor out the 4z. The 1 minus z and the z minus 1 are almost the same. We'd love to be able to cancel those to 1 and divide those away, but it's not quite there. However, if I use this handy trick, I can flip-flop the a and the b. I can flip-flop the 1 and the z by dividing out a -1. So if I make this a -4z, I would get z minus 1. And if you distribute through, -4z times z would be negative z squared, 4z squared, and -4z times -1 would be a positive 4z. So we do get that original expression again if you divide that through. And by doing that, by taking that extra negative out of it, I'm able to cancel the z minus 1 and the z minus 1 and say that my final simplified version would be -4z. Again, in this case, we only have this one variable, and so we could say z could not be 1. So the excluded value, z, would not work if it was 1. This takes practice. I'm actually gonna stop here because I think this is gonna be a really long one if I keep going. I'm gonna break this one up into a couple different sections. So I'm gonna stop here with this handy trick, and I'm going to give you a little bit of a brain break, and then I'll do a second video for multiplying and dividing. I'm going to do another video after that for adding and subtracting.